Testing. Okay, I hope this works. I don't know if the volume is coming through, but what I've decided to do today, since nobody turned up for class today, I know that two of you said that you would not be here today. I thought the third person would be here, but apparently that person decided not to come, maybe because of the other two not coming. So what I've decided to do is to record the lecture plan for today, which basically is based on chapter 4. So what I'm going to do now is share my screen. Okay, so we're going to start with chapter 4 today, which deals with compounds and the type of bonds that exist between atoms and ions in their formation. So let's talk about firstly this whole concept of the octet rule, which is a fundamental and important idea in chemistry to explain ultimately the type of compounds that are formed between elements. Okay, so when we're talking about an octet in chemistry, we're talking about 8 electrons on the valence shell, all right? So octet means 8, obviously, right? And what was found is that this concept, or the fact that you have 8 electrons on the valence shell, is associated with the stability of atoms that contain that particular feature. And that is particularly true for the noble gases, those elements in group 8. Now, helium is an exception because helium has only one shell, and that's the first shell, and its maximum capacity is 2. So therefore, we call that a duet, and there's some stability associated with that as well. But for the other elements in that group, like neon, argon, krypton, you'll notice that they all have 8 electrons on their valence shell. And these elements are also very stable. They do not undergo many reactions. In fact, krypton undergoes some reactions, but you have to apply some real special conditions. And the same is true to a lesser extent for argon. And as far as I know, helium and neon are not able to form any compounds. Nobody has been able to form compounds with these elements. So they're very stable. They're very happy and satisfied with their arrangement, which would be a full outer shell. In the case of helium, that's 2. And in the case of the others, that's 8. All right. So atoms that don't have this feature, they tend to try to obtain that feature, and they do so by either losing or gaining electrons, all right? So what you'll find is that metals, they tend to lose electrons to obtain an octet, and nonmetals, they tend to gain electrons in order to obtain an octet. Or in the case of nonmetals, again, they tend to share electrons. And what you're going to see here in this diagram is a situation where you have a metal with 1 electron on its outer shell, and it's donating that electron to a nonmetal which has 7 electrons on its outer shell. So therefore, when that transfer of electrons occur, you end up with this structure here, which has 8 electrons on its outer shell. So that's one way a nonmetal can form a structure which has that feature. In the case of the formation of what we call covalent bonds, you have electrons being shared. So you have these 2 nonmetallic atoms, each of them have 7 electrons. When they share the single electron that is shown here, you're going to end up now with both atoms having 8 electrons on its outer shell. All right. So we can have some situations like this where we have what is known as a covalent bond being formed as a result. All right. Okay. So some general trends that are normally observed. 1 minute. Some general trends that are normally observed. Metals, they tend to form positive ions by the loss of their valence electrons. And the resulting structure will have a noble gas configuration. In other words, 8 electrons on its outer shell. As a result of losing their electrons on their outer shell, they will end up now with less electrons compared to the number of protons present. And as a result, the structure will have an overall positive charge. So what you'll find is that group 1A metals will tend to form ions with a +1 charge. Group 2A metals will form ions with a +2 charge, and group 3A metals will form ions with a +3 charge, all right? So that's what happens in the case of elements belonging to group 1A, 2A, and 3A, the metals that belong to those groups, all right? So just to use an example, let's take the sodium atom. Sodium has 11 protons and 11 electrons, and the electron arrangement or configuration is shown here. 2 in the first shell, 8 in the second shell, and 1 in the third shell. And what happens easily for sodium is that sodium will tend to lose an electron to form this resulting structure. You'll notice in this structure, you have 11 protons and 10 electrons. So therefore, basically, you're going to end up with a structure with an overall charge. Since you have 11 protons and 10 electrons, the overall charge will be +1. So therefore, we write that symbol Na with a plus as a superscript to indicate that the charge overall for the ion is +1. And you notice as well that the electron configuration of sodium is changed from 281 to simply 28, which is the electronic configuration of the nearest noble gas element, which would be neon, all right? So that's what happens when sodium loses an electron to form the sodium ion. And the next slide I'm about to show you shows you basically the resulting charge. As I said before, you have 11 protons in the ion after the loss of the electron, which means that you have 10 electrons. So therefore, the overall charge is +1, all right? So let's look at another example, magnesium. So this is the electronic configuration of magnesium. You'll notice that magnesium has 2 electrons on its outer shell. So therefore, it will lose those 2 electrons. And as a result, the resulting magnesium ion will have now 12 protons still, but 10 electrons. So that means the overall charge will be +2. So therefore, that's the formula for the magnesium ion. And as you can see, the electron configuration changes to 2,8. All right? Okay, and that shows you how the charges are calculated. They have 12 protons, 10 electrons, so therefore the overall charge is +2. So that's the formula for the magnesium ion. So these are some learning check problems. You can look at these on your own and see if you can answer them. And these are the answers. All right, normally I would ask you to answer these questions. So let's look at the formation of negative ions. Now, in the formation of negative ions, you have nonmetals, which belong to group 5A, 6A, and 7A, and what they tend to do is gain electrons. And the number of electrons gained is dependent on which group they belong to. So elements in group 5 tend to gain 3 electrons. Elements in group 6A tend to gain 2 electrons, and elements in group 7A tend to gain 1 electron. And therefore, they will form ions that are negatively charged with charges of -3, -2, and -1, respectively. All right, and again, in each case, what they try to do is obtain an octet, 8 electrons on the outer shell. So for example, if you take chlorine, which is in group 7, and this is the electronic configuration of chlorine, then in order for chlorine to achieve the octet, it will gain 1 electron here to form this arrangement here, all right? The result, of course, is that the chlorine atom will have 1 more electron compared to the protons, 18 electrons to 17 protons, and therefore will have an overall negative charge, all right? So that's what happens in the case of chlorine. And this shows you how the charges are calculated. You have 18 negative charges, 17 plus charges, so therefore the overall charge in the case of the chloride ion is -1, all right? Okay, so let's talk about how the charges are calculated for the different groups. And we covered this just now. So just to summarize, in the case of the elements, the metals from group 1A, 2A, and 3A, the charges are +1, +2, and +3 in the ions that are formed from those groups. And in the case of elements belonging to group 6A to 7A, you take the group number and you subtract from it 8, all right? So 6 minus 8 gives you -2. So all elements in group 6A will have a charge of -2 in their ions. And if it's group 7, then it's 7 minus 8 gives you -1. So therefore, all elements in group 7A will give you ions which have a charge of -1. So this basically summarizes what I just mentioned, all right? And you'll notice I don't think I made this statement before, but basically the configuration adopted by the ions will be the same as the electronic configuration of the nearest group 8 elements. So all these elements, for example, all these ions, nitride, oxide, and fluoride, these all have the same electronic configuration as neon, all right? In the case of these ions here, they will have the same electronic configuration as argon, and so on and so forth, all right? Okay, some more learning check questions coming up here and their answers, so you can look at that on your own. All right, so I'm going to stop this video here, and we're going to look at let me see here. We're going to look at some other. We'll continue this next class. Let's put it that way. I think I'll just stop here, but I just want to get you guys introduced to chapter 4. All right. Okay. Until